So, welcome to week 10 of RC3. Glad to see all of your guys' smiling faces. Most of you have smiling faces. Hopefully we can put a smile on your face at RC3. So definitely go to RC3Club/sign in so that we can give you guys cool prizes, get cool sponsors, and all that. So, do screen mirroring. That helps. Yep.
How was that even open?
Different monitor. Alright. Now that we're all on the same page together. Alright, so the social engineering exercise is now officially over. My life can go back to normal without having to worry that you guys are going to stick spoons in my pockets. So only one person got me, which is Brandon DeSantos. A lot of people tried, but they failed, so they'll get points for that. If you guys want to continue sticking spoons in my pocket, go for it. I don't really care, but you won't get points for it. So if you want to continue social engineering me, go for it. I mean, if you guys want to continue to exercise, that's fine. You just won't get points for it. So we're going to start off with news. All our presentations are online today. I already got them up. They're good to go. I'm on top of it today. Go for it.
Alright, so 15% of routers are using weak passwords and 20% of them have telnet ports open. So this is kind of in the news indirectly and directly past couple weeks with the Mirai botnet and all that kind of stuff. Default credentials on routers is pretty much the main way that routers are kind of being hijacked and used in these botnets. And so this Slovakian cybersecurity firm, ENCT, they scanned 12,000 different routers, and they found that 15% of them are using weak passwords and 20% of them have telnet ports open. So if you guys are using your own routers, I don't know how many of you might be, but if you are, you probably don't have weak passwords set and telnet open, but just in case, just give it a check, because our IT should be part of botnets. That's kind of bad news. Also, don't shoot your router. Routers are people too.
Yeah.
By definition, they're not. So Microsoft is starting to do this thing now, where they're gonna every Tuesday, they're gonna push out patches to their machines, and depending on which Tuesday of the month it is, it's gonna be a different kind of patch. So the second Tuesday of each month is gonna be security patches and stuff, and then the third Tuesday of every month is gonna be upcoming features that aren't security patches. And what that's gonna do is it's gonna allow companies who are using Windows machines in a production environment to be able to test whether or not the upcoming updates are going to still work with their system and if it's just going to break if they update, and allow them to roll back if it does break. Whether or not that's relevant to you guys, I guess it could be if you're on Windows and you aren't sure whether or not you want to update to the latest version, like from Windows 7 to 10, if they haven't forced you to yet. But yeah, so Tuesdays you'll probably see updates coming into your computer if you're running Windows. So who heard about that Linux kernel privilege escalation vulnerability? Yeah, so that's a pretty big deal. It's called Dirty Cow. Cow stands for copy on the right, which is explained in this blog post. So this post is a really good kind of simple explanation of how it actually works. If you were wondering, how does something like this actually come to be that you can gain root access on any Linux kernel running I think 4.4 lower, lower than 3.9. Yeah. So this blog post kind of just runs it down. It looks over some of the example code. If you go to dirtycow.ninja, it's a website that kind of explains the vulnerability, and there's proof of concept code and stuff on there. So this blog post kind of goes over the code and explains it in a very simple manner that kind of anybody can understand, even if you don't really C to a good level. And then it explains how race conditions work, being that one thing goes and another thing goes, but if you have two things that are doing those at the same time and they go at the same time, then shit breaks. Yeah, so it's a cool fix, and he talks about like how the fix actually works very briefly, and yeah, there's a bunch of sources here at the bottom too. So if you're interested in like kernel exploits.
So wasn't it interesting, because me and him were looking at this last week, that like this is like a vulnerability found like 10 years ago, and then someone never fixed it.
Yeah, they actually tried to fix it.
Yeah.
Yeah,
They're like, it broke our stuff, and then they just
Yeah.
never went back and fixed it. They're like, well, it's too hard to do security, and well, we don't want to fix it because it breaks our other stuff. So we'll just leave it as is. So things like this happen.
And just like in the future, actually, if you're like trying to find maybe some like kind of bug within the Linux kernel, this has happened more than once. This happened with 4.8. There was some like really bad bug that was pushed into like production in the 4.8 kernel, and Linus Torvald got really mad about it because they had tried to fix it like 10 years before, and it didn't fix it, and like he's like, I can't believe these fucking people are not fixing this. Like, this is your job, anyways. But yeah, so just like look for shit that was like trying to be fixed and then reverted it, because that's probably still a bug. So that big DDoS attack that took down like a lot of the internet, it was 100,000 devices, which is really not that many, and it was mostly Mirai botnet. So it was originally stated that part of it was Mirai, but now after DOIN has done like a lot of research on it, they found that most of it was actually Mirai botnet. Well, a Mirai botnet, because there's like a lot of them because of the source code. Yeah, so it was only 100,000 devices, which is really surprising, and it's also been noted that it's kind of been running around hitting other places. Yeah, so earlier on actually, like in August, there was like a 280 gigabit attack, which is like, compared to the full attack that hit like Krebs and DOIN, it's really not that much. But that's kind of like an indication that it's been going like around for a while. So yeah, kind of just related to that router thing. Make sure your routers, if you have a CCTV camera, for some random reason, lock that down, because most of the devices are CCTV cameras, it said. So if you're like a security nut that has IP cameras, at least make sure that nobody else can get into them. Yeah. Who has an iPhone? Okay, not that many, but still, if you have an iPhone, there's a vulnerability that's shown up that an image, PDF, or font file can just basically get a shell on your phone, and that's really vulnerable, and it can work on Apple TVs, it can work on Macs too, but Apple has pushed out patches on, I think, all their devices already. So macOS 10.12.1, which is the latest, I updated to it yesterday. You can get it in the App Store. That should patch it. iOS 10.1 should patch it, and if you have an Apple TV, 10.0.1 should patch that. Yeah, I think that's it for now. Oh, one more thing. Google search terms has some interesting information. Memes are officially more popular than Jesus.
We did it, Reddit? Alright, so moving forward with today. So Kyle, you want to come up real quick? So there's a UV competition. It's on the 19th. It's going to be Saturday, November 19th. So I'm going to let Kyle take it away.
Hey, Kyle.
Hi, Kyle.
Thanks, Brad. So, red team versus blue team competition, November 19th. You should totally sign up. Registration link is over there in the corner. Red team versus blue team, you come in as blue team, you get hacked, you win a lot of cool things. You go home sad and happy at the same time. It's like a bunch of mixed emotions. If you want a white team, you should come talk to me. White team essentially are the people that manage like the competition, like the infrastructure. So if you want to volunteer and like help out, that's a cool way to get involved too if you don't have a team. I know they're definitely looking for some helping hands this year, so that would be cool. Do you guys have any questions about like all that information? Because that might not make sense to people. Joe.
How are you gonna hack me?
I'm gonna what you're gonna be doing? No? You guys all excited? It's gonna be fun.
Alright.
Cool. Thanks.
Alright, so as you all know, Grim is doing co-op opportunities for juniors and seniors, so please contact Jamie if you are interested in doing that. So he'll be here the week after we get back from Thanksgiving. So we're one of the clubs here in Gossano is having an event. We're going to have one of the representatives come up and talk about two of the events that they're going to be having. So come on up. Yeah, that's on the next slide. Thank you. Yeah.
Hey guys, my name is Christopher Sprague. I'm the secretary for the computer science community. As you can see on this slide, we're hosting an Artemis event. I'm not sure how many people have heard of Artemis. It's a spaceship bridge simulator, and at the risk of sounding kind of nerdy, it's kind of like you get a chance to like be at the helm of a Star Trek ship. So there's a bunch of different positions. You can sign up as a team or as an individual, and we'll put you on the team. There's going to be free pizza, and there's no date on this, but I can get you the date. That is Saturday, November 12th, 5 to 8 p.m. in Gossano 3560, and that information will be on our website. Yeah, free pizza, learn how to play Artemis. It does require Windows Box to run, and what we're looking for with this is get a bunch of Gossano-based clubs, basically, and just every club has their own ship, and like, you know, whoever has the winning ship, you know, PvP, kill them, all that good stuff. Perhaps on a more relevant note, I understand CS1 is a required course for CSEC majors. I don't know how many people are still in CS1 here, but this Sunday, so the 30th, 3 to 5 p.m. in this room, Gossano 1400, we will be having the CS1 exam review. So we give you an exam review, you work on it for an hour, and then we go over the answers together for the second hour. Free pizza, free drinks, and yeah, it helps people get prepared for these exams. Obviously, I'm a little biased, but I took them back when I was in CS1, and they were really helpful. So, yeah, and also we have another one for CS2 if you're in that course the week after that. So yeah, if you have any questions about any of that, please feel free to contact me or check out our website. It's csc.cs.rt.edu. And thanks.
Thank you. So for someone who doesn't like programming, which is me, I went to these reviews all the time and they were actually really helpful. So Hacktoberfest is something that's happening on DigitalOcean, so it's trying to collaborate people to write more open source code and push it to GitHub and stuff like that. And if you push a number of commits up to their website, they'll send you a free T-shirt. So
I think it's actually like pull requests, so it needs to be like code of relative.
we'll accept your pull requests. If you set up the RC3.
Code of like relative decency. You can't just be like, yo, I added a comment, yo, I added another comment, git push, YOLO.
Some ROT students may have done that the first year and they learned from their mistakes. So.
Couldn't you just make 2 accounts and just keep accepting pull
Sure,
requests?
there's always a way around it. So, as you guys have heard over and over again, we're going to be having our CTF starting Friday, November 18th. It's going to be going the entire weekend. We're going to have different categories such as web, forensics, reversing, crypto, and trivia. And we're going to have sponsors be donating challenges. So we had an e-board meeting yesterday. We talked about RC3 swag, which we're going to be talking about on the next slide, because I know all of you are really excited. We're trying to get a resume bank created so you guys can upload your resumes and sponsors can go pull down your resumes and come hire you guys. So that'll be really cool. Working on setting up a second server for you guys, the pentest RC3Club. So we're going to set up a web server so that you guys can actually test out and find vulnerabilities in our own website. So we're going to try and get that done within the next 2 weeks so that when you're done our 2-week rotation of web, you guys can actually go pen test our website and let us know if you find any vulnerabilities. So you get to do it on a real website. So, but more details to come on that. Do not hack RC3Club at all. Don't. If you do it, we're going to have a conversation that you don't want to have. Okay? So, making sure that we are on track for creating challenges for the CTF. And we're going to be upgrading our photo used on the homepage. So, we're going to be releasing more information on that in the coming weeks. But we're going to be taking those photos during club time. So if you don't want to be in the photo, we'll have a way for you to opt out of that. So RC3 swag. Finally here. I didn't think that you guys were going to be so excited to get RC3 swag when I said it, and I got like so many people each week going, "Where's the RC3 swag?" And I was like, "We're working on it, we're working on it." And so I finally went, "All right, we're gonna take it from a semi-medium priority, we're gonna bump it all the way up to the top." So I put my team on it, and we finally have swag for you guys. So there's two options here. So we have this first one here, which is one color base, which is just white, and then we have over here, which is a color one. That color one is going to be roughly $30. That's not a set in stone price. It's going to be roughly $30 if we want the color one, but it's going to be $20 for the base color one, which is just all white. And the t-shirts are going to follow the same design. So it says on the back shirt, on the back of the shirt, "We are damn passionate about security," and then it has the RC3 logo on the front. So those are the swag that we're going to come up with. So.
Are those zip hoodies or?
No. And then, what's
Are
up?
those zip hoodies or pullovers?
They are zip hoodies.
So there should be two options. There's zip hoodies and then there'll be a t-shirt option as well.
So I wanted to release this to you guys. We'll release it officially when we have official prices and everything, but I wanted to give you guys a view of what we have designed and all that. So hopefully within the next week we can have official prices and a sign-up form. And our hope is to get you guys on the sign-up form and get these delivered here before you guys leave for winter break. So that's the hope. And then some social engineering highlights from this week. Some of you got really creative, and it was a lot of fun to be on the other end and watch all of this. So someone set up an ITS service desk email, which is really cool. So they had this show up, and they set urgent and all that. Like, this is a lot of work. This is really great. Someone created this login page, which is really great for Gmail. And then up there, they did the same thing for Facebook. So some people put a lot of time and effort into this, and that was really cool. And this is the type of stuff that I was looking for you guys to do during this exercise. So one thing to, so here's the thing. Someone sent me this and then never, they sent me this, and they were so close, but they never responded to my message. If they had just sent me a link with a login portal, I would have given them their credits. You were that close. I wouldn't have given you to it in a chat, but if you would have sent me a login portal, whoever you are, I would have given you the credit. You were so close because you used Scott Freedom Slinger, you created your own account, and most people won't notice that. So that's really cool and really creative, and whoever did that, bravo. And then there was Karen, which was really super creepy and really awesome at the same time. So, for those of you who don't know, Susie Joe Donuts is a local donut store in my hometown, and she's the manager of it. She went to my high school, and she's from my hometown. So someone social engineered me and created this account, which is super creepy and super awesome all at the same time. So, well done, bravo. That was really fun to look at. So. And then James was also another thing. So just so you know, Karen and James, I had nothing to do with that. So someone else created them, so I'm sorry if you spend a lot of time doing that. That's just part of social engineering. It's still around the good and the bad. But on a most serious note, I really liked all the social engineering. You guys were really creative. It was a lot of fun to see it. And I loved all the creativity. But if you created Karen Weber Jenkins and any other fake accounts that are associated with names that we have for this week, if you could go and delete those accounts so that when we reuse these accounts next semester or next year, that we don't have all these fake accounts that people are associated. So we can start with a clean slate so that people aren't confused with who's who. So if you could go do that, that'd be awesome, but really impressive. And we're going to go over social engineering and how you're supposed to solve all that later on. So we're going to start with web. You ready, Nick?
Just about, yeah.
All right. You want to do it on my laptop or you got it?
You'll do it on your laptop.
Okay.
No.
Oh shit, I did this one. Nick, I forgot to get a bar today.
What?
I forgot to do what I told you about last night.
Yeah, I know, I saw. I had a little bit more.
I can do it next week. I just got really sleepy.
Okay. So, everybody, today we're going to talk a little bit about web. After this, Spider-Man's going to be so proud of you guys. Here's my normal disclaimer, and I got another disclaimer for you. This is now a Spider-Man thread. Deal with it. So, what is web? It's the first thing people hear, or they think when they hear the internet. If you say internet to someone, who doesn't know how to compute it, they're like, oh yeah, that thing I click on, I go like Internet Explorer and stuff, right? So what makes web work? It's an amalgamation of all these different technologies that makes fancy, good-looking things or some really nasty-looking things show up on your browser. That includes HTTP, which is a hypertext transfer protocol that basically sends everything you need from one server to your client machine so you can get it. HTML is the basic framework for what you're actually seeing on the page. CSS makes it pretty, and JavaScript makes it move. That's the simplest way to put it. So there are several different servers that are often deployed. You'll see Apache and Nginx, and then IIS. Apache and Nginx are Linux variants, and then IIS is Windows and Internet Information Services. So alongside, you can have a whole bunch of things called databases, right? So if you want to actually have like an application, not just like some static page that's got some info on it, you want to like have a login or something, you just store information like users, their password hashes, their credit card numbers, a whole bunch of stuff, right? You store something like that in a database. So some kinds of databases there's structured and unstructured. Structured is very rigid. That's something like structured query language. That's that first table up there. You'll see that we have columns for like the field, the type, the collation, and whatever. And you can see that for this individual table, there's an ID, there's a title, there's content ordering, and they all have set values. You're putting things into a box that it's supposed to go in. Then you have things like unstructured databases, where it's literally just like a heap of memory, and you can just throw whatever the heck you want in it. You can essentially create a structure containing whatever fields you want. In this one, you'll see like the blog post has an ID, an author ID, and like a date and a rating. But like the comments also have an ID, but they have emails and they have upvotes and other things. So this allows things to differ, and instead of making a large, complex relational database that has very set slots for everything, you can create things kind of on the fly with an unstructured database. So in order to do more things with web server and be able to get it to do things, be more interactive and actually program it, you're going to need like a server-side programming language, something along the lines of PHP, Node.js, Ruby on Rails, or Flask to do all your back-end programming. So, HTTP, it's stateless and request-oriented. So what does that mean? Can anybody tell me? Anybody? Joel, you had your hand. Like a good student.
What happened?
Yes.
Now,
Stateless is just like, there's no like starting endpoint. It's like
yeah, so a stateless interaction is I go out to Jesse's web server that Jesse has, and I say, hey, give me this thing you got, and he gives me that thing he got, right? So I get the thing, the connection's done, that's it. If I go back later and say, hey, give me another thing, and be like, okay, he asked for a thing. There's no really correlation that I'm the same person other than I have the same IP address, right? And it's for the speed of the web server so that you can quickly request a file and pull it down. So in order to implement something actually kind of like a session, to actually log into a web server, you need something along the lines of a cookie, something that proves you're you. So if you go out to a web server and you prove it yourself, give them a username, give them a password, they'll be like, awesome, have a cookie. So you get your cookie, and then every time you go back to the web server, you say, here's my cookie, this is me. You can tell it's me because I have the cookie that you gave me. And if the cookie matches, and if you provide the proper credentials, you can match up the user and provide them a seamless experience over different pages that's catered to them. So HTTP has a bunch of different methods. You can see them all here: head, get, post, put, delete, trace, options, and connect. So HTTP get and HTTP post are the most common that you'll see in everyday traffic. Get is it's exactly what it sounds like. You're going and you're getting something. You give a URL and it says, hey, get me this resource. If there are any parameters that you need to pass to a backend scripting language or to the page itself, you pass it in the URL. You'll see that in here we do a question mark and then we put a parameter and then we put an equal sign and you put your parameter there. This is what it would look like in a URL bar. Pretty sure you're all pretty familiar with that. But if you've never used something like Burp Suite, which we're going to get into later, which is a proxy, for now, I'll just tell you guys it's something that sits in between your requests. You send a request, Burp goes, no, give me that first. Okay, now I'm going to send it. You can manipulate it the way you want to test the web application. But we'll get into that a little more. So this is what the actual request that the application is sending to the web server actually looks like. So the post sends data to a server. And instead of having the URL or all the parameters be in the URL, they go in the body, right? So if we go back here to this get, after this connection closed, down here is where there would be extra information. You would put something like the parameters that you need for the web application. It could be JSON, it could just be another variable equals whatever. But this is how you submit data or to a page, not through the URL. And this is what's most often used for most action on RESTful APIs, and that's something we can get into at a later time. So methods that you really shouldn't allow or shouldn't be using are put, delete, and trace. If you're just hosting a website and you're not having anyone being able to download things from your server, you probably shouldn't allow them, or put things on the server, you shouldn't allow them to actually put things and upload things on the server, just like you shouldn't be allowed to let an arbitrary user delete your stuff. And if you're going to have these methods, put them behind some sort of authentication wall. If the better way to do it is to make sure that you use a post request and hit an API endpoint that would do the thing for you instead of calling this method directly. The trace method allows the client to see what the server is actually seeing. So if there's any filtering or anything that it's doing to the request that isn't public knowledge, if this method is allowed, you can request the trace method, and then it'll give you some more information. It's generally something you don't want to do if you're hosting a production server. So HTTP also returns things called status codes. I'm sure you've seen 200 OK and 404 page not found before. But this is the status of them. 100 is informational, 200 are things that went well, 300 are, hey, this thing got moved somewhere else, 400 is, you done fucked up, please fix your shit. 5 is, we fucked up, we're gonna fix our shit. So, back to cookies. You get a cookie from a website, you say, I have the cookie, and you authenticate it, you present it to the website, and they say, okay, you are you. Some common ones that you can see were the PHP session ID, JSession ID, CFID, and CF token. Those are for Cold Fusion, which is Adobe's web development framework, or rapid web development framework. And then you see ASP.NET _session ID, which is the Microsoft .NET web framework. So, basics of HTML. It's a tag-based markup language. It's got open and close brackets. This allows you to start a basic web page, and it has something called the document object model. Essentially, it's the HTML tree. So as we'll see on this next slide, this continues to go down. So we have HTML, which is the large section, right? And then we have the header. This is what's going to show up on the tab for your in your browser. And you'll see that this is here. And then we have the body, which has some stuff. We've got some text written out here in the form of a header. And then we have a link being made, right? So this is all contained in a tree of sorts, if you're going to think of it as a data structure, whereas the HTML bracket is the root node, and then it has a head node that branches down and a body node that branches down. So CSS, cascading style sheets, make things look pretty. Makes things that look like this turn into this. I know Sean has a lot better plans for our site, but basically this is what a basic HTML page looks like. You've probably seen this before, and something with CSS and JavaScript is going to make things look a lot better, add colors, and just be generally easy to work with. JavaScript, like I said before, it's what makes things move on a page. If you want to do really anything with a page, if you want something to start on one end and fly around and go to the other, perform animations, do something, that's what it's going to do. It's a full-blown scripting language, so you can program anything in it. It actually has a server component called Node.js, which some people use to do their back-end scripting. It's got full access to the document object model, so if you wanted to access the cookie of the document, you just be like, oh yeah, write document.cookie. You can interact with everything that's in the request. Also, fun fact, JavaScript has absolutely no relation to Java. They were both developed in the 90s, and apparently they all really liked coffee. So, getting to the end of the intro to everything, intro to MySQL. So it's a relational database, and database is really just a set of tables, and those tables have columns, and those columns define attributes. So if you had like a users table, they might have a user ID, they might have a first name, they might have a last name, they might have like a username, they might have a password hash, right? So those would be fields that are in that table. And then there might be another table that contains other things, and you can relate those tables together. So individual rows would be an entry. So if I had an entry in the users row, my ID would be automatically assigned, my username would be Nick is super awesome, my first name is, well, Nick, last name is Nick, and my password is, Nick is super awesome, because I'm awesome at security, right? So there's a row for each individual entry, so for anybody who would sign up for said website that had that database table, you would have a row in the table where it corresponded to all of your information. So SQL is really its own language, and all of the various implementations have like a different spin on the language. So like there's different kinds of SQL like PostgreSQL, MySQL or MariaDB, SQLite. There's a ton of them, and they all have slight variations. Microsoft SQL as well. So if you've never done any SQL before and you haven't taken a database course, this might be a little wacky to you, but I'm going to go over some commands and how to interact with SQL from a command line environment so you guys know what you're doing. So to interact with the command shell, you just do the MySQL command, you do the U for the user, and then P, and you put your password in. You can also specify things as remote hosts. So if you wanted to log into a SQL server that was in China, you just give it the IP address, right? So we have this concept of databases, right? So if I put in the show databases command right here, I can see all of the databases that are available. There's information schema, authentication models, MySQL, RIT-DCE, and performance schema. This is from a lab that I just did for the authentication models course, and then I had 2 databases in here. Information schema, performance schema, and MySQL are normally defaults for MySQL or MariaDB. So if we want to switch to a certain database, you have to say that you want to use it, right? So for my lab, I had to use my authentication models database. So I literally type use authentication models, and then I can switch to that database. So one thing to note about SQL is that it requires semicolons at the end in most cases, except for like weird cases where you're switching databases where you don't need to. But if you want to show the databases, you do need it. But if you want to use a database, you don't. But if you want to do a command, you do. Little wacky. So in a database, you want to see what tables are there, right? So you would simply do a show tables. And this is getting pretty simple, as you can see, right? And you can see that there's a names table. And then if you wanted to describe the names table to see what columns it had, you would say describe names. And you can see what it has. There's an ID, a first name, and a last name. You can see that the ID increments automatically and cannot be null. And for here, this is where we get into basic SQL syntax. So I want to get data out of this table, right? So in order to do that, we have to select the data. So I say select, and then this little star here, which means everything. I want to select everything from names. So basically we're saying, hey, give me everything from the names table. And MySQL complies, and it says, okay, there you go. Got all your data there for you. So we do that again. So let's say we only wanted to select specific attributes, right? So let's select only the ID field and the last name from the names table, where now we're adding a condition, the last name equals another, right? So if we look over here, we have the entire table. We're selecting out the ID column right here and the last name column. And then what we're doing is we're saying, okay, now that we have this table, we're only selecting what columns we want. We go over and find where the last name equals another. Okay, so for those entries 5, 6, and 7, those are the ones that match the case over there at the end. So we're going to give that information to you right here. Are there any questions for anyone who hasn't done any SQL before? Any questions at all? Really? Good? Okay. So what if we wanted to do something a little more wacky? What if we wanted to get information from another table? We would use something called a union, okay? So we're doing the same kind of thing that we were doing. ID putting things where they don't belong. Kind of like a little kid in a Gorilla playpen. So these can be these can be along the lines of injecting commands to the operating system. It could also be along the lines of injecting commands to a SQL database like we just saw before, or it can be inserting HTML into the page. So for command injection, we have that server-side scripting language that I mentioned earlier, right? They sometimes might load a file or something, or you might check to see if a host is online. Like, let's say an IT administrator make a tiny little page to be like, okay, I want to see if this host is up. Let's just do a ping of it and see if it's up. And they don't code that right. You could potentially escape that and inject other commands. So let's just take the ping command first of all. If we're accepting ping, and we put 8.8.8.8 in, it'll ping 8.8.8.8. But what if we were to put 8.8.8.8.8 semicolon ID? You put it in there, and it would actually recognize it as two separate commands if it's not being run properly. So you would then, it would essentially run the ping command, and then it would run the ID field, or the ID command. You could substitute the ID command for anything you wanted. Maybe if the version of Bash was old enough, you could use a shell shock vulnerability to literally whatever you wanted. Or you could just execute whatever you wanted because you're essentially given a shell one line at a time. So thinking about injection from a SQL standpoint, let's do a regular login, right? Select star from users where user equals this and password equals this. So as we go on number 4, this is kind of what's going on here. Select is the action. We're figuring out what we want to select, the table we're going to select it from, and then what's actually being supplied for the parameters. So normally in PHP, you're going to see this kind of syntax. So whenever you want to get something out of a post request, you need to do $_post, and then you access it kind of like an array, or you access it like a dictionary in Python. You give it a key and it'll pull out a value. If you wanted to get something from the URL parameters in a GET request, you would simply replace the $_post with $_get and just reference the variable that you passed it in as. So if we put Bob, he logs in with password, that's awesome, right? Bob gets to log in and his password is password. But what if we were to put in Bob, single quote, semicolon, $? What does that do? Well, we see the first quote right here, right? What we do here is we put in that second quote to say, okay, stop that field that you're doing right there. I'm done with the username field. Okay? And then I'm going to put a semicolon in, which is the end of command for SQL, and then put the pound sign in, which is the comment out the rest of the line. So we've essentially gone from this SQL query, where it's saying select everything from where this username and password actually matched, to saying, hey, give me just this user, right? And we've completely gotten rid of the password parameter entirely. So what if we were to do this with like, or 1 equals 1? What's going on here? So what's actually happening here is we've actually added more to the SQL statement. So we've started out with a simple statement, find exactly what I want, and then modify it to do something else. So in this case, what's going to happen is you're going to find it where a username equals Bob, or 1 equals 1. What does 1 equals 1 evaluate true? Evaluate 2. I just said it in the thing. 1 equals 1 evaluates to true. Spoiler alert. So what you're doing here is you're creating, hey, find this where this is equal to this, or 1 equals 1. So what's going to happen is it's just going to dump everything out, because you told it to select everything from users where this is equal to this, or 1 equals 1. Well, 1 equals 1 is always true. If it's not, you've got a bigger problem. And then it's just going to dump the rest of the stuff out. So, under cross-site scripting, this normally involves JavaScript. There are some other scripting languages that are out there, but JavaScript is the standard for what you're going to see out on the web. You can put it in the middle of the page. So if you use a script tag, it would just be bracket script bracket, whatever your JavaScript is going to be, bracket slash script bracket. And if you can get your JavaScript onto the page when it's not supposed to be, that's called cross-site scripting. You're scripting from a different site. And there's 3 different types. We're only going to cover reflected and stored today. DOM-based is referring to the document object model. It's a lot less common as opposed to reflected and stored. It's normally used to get around other mitigations that have been put in place to stop you from being able to do things. So, reflected. This is normally what you'd see in don't click links from emails. So this normally works with a parameter that's passed in via get, right? So we'll see over here that we've got some page, we've got a parameter, and we can put in whatever we want, right? I can put in script alert XSS, which is just going to pop up a box and says, you got cross-site scripting on your page, and then close it up. If the web page is interpreting this and writing it to the document without accounting for there being potentially dangerous characters in there, such as the script tag, it will execute on the page because you've written it to the HTML document. And what a web browser does is whenever it gets a document, it runs everything that's in the document, because that's how the protocol works. You requested a piece of information, you got a piece of information, you assume it's correct, and you run it. And that's how the protocol is structured. So reflected XSS is better for like a phishing and spear phishing kind of thing. It's what you're normally going to see it as. You can always hide whatever your link actually is by making link text and then putting the link inside. And this only affects the current user. So that's why it's reflected cross-site scripting. It's like it's bouncing off a mirror. So I can click that link and it'll work on me only. And if Ben goes to that page and he doesn't supply that parameter, that's not going to work on him. And if I were to send this link to Ben, if he clicks it, it'll work on him. But if he goes to that page and it doesn't have those parameters, it's not going to work. And it's also not going to affect anybody else either. That is the opposite of stored cross-site scripting. Stored cross-site scripting is where we take that malicious thing that we have here, the ability to put in any JavaScript, and store it somewhere on the server. So we have that database that we were talking about earlier that has all username and password information. What if I replace my last name with script, my malicious JavaScript payload that can be anything we want, and script. Whenever I log in and it displays my last name, it's not accounting for anything. It will just execute that script as if it was on the page normally because it's being loaded from the database, which is a trusted source. So another thing you could think of where this would go would be on a comment field in a website. So let's say someone makes a blog post and you're allowed to comment on it, right? If I wanted to do something with a malicious payload, it would be, here's my super duper awesome comment in the middle. I'm going to stop, I'm going to say script. I'm going to go out, I'm going to get this malware, or this JavaScript payload, and then I'm going to continue on with my comment, right? What's going to load up on the page as is, oh, here's my super duper awesome comment that's in the middle of the page. This will never get rendered because what the browser is doing is it's taking this as an instruction that it needs to run something. So it's going to see this, it's going to go get the malware that it wants to do, it's going to run it, and then it's going to continue rendering as normal, and you won't see anything different about it unless there's something like an alert box that's changed on the page, or you put an image on the page, or you specifically modify the page. So, talking about a tool called Burp Suite. This is something called a web proxy. It sits between you and where your traffic is going to go. So I set up a proxy on my machine. I can inspect all of the requests that I want to make, and we can fiddle with what the application is expecting as opposed to what I want to give it, right? And it has a whole bunch of tools for that pen testing. This is the tool that I've been the most familiar with. There's a free version that a lot of people use. There is also a pro version which has a few more features. Definitely get to know Burp Suite, and then we'll give you guys a quick intro right now. So this is the general overview of what Burp looks like. You got a whole bunch of tabs. There's target, proxy, spider, scanner, blah, 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 blah. Whole bunch of stuff. So in your proxy, this is what I was talking about where you're stopping it. You're inspecting the request, right? We can see that I have the request here, and I can modify any of these parameters that I would like. So you can also see the HTTP history. So you can see everywhere that your browser has gone, you can go back to it, view the request that you sent, and the response that was sent. So let's say you find now something that responded a little bit wacky when you played with it. What you can do is if you press Control-R or just right-click and then send to repeater, you can actually take a specific request, modify whatever you want, and send the same request over and over again. So if you want to fiddle with like one specific parameter trying to inject something, you can go to repeater and work on that specific endpoint there. I spent a lot of time working in this over the summer. Repeater is super awesome. The intruder tab is like an automated scanning and cross-site scripting like injection kind of thing, but that's the paid feature. It's pretty useful, but I think the license is about $400 for Burp. There are other open source alternatives. Burp is just one of the better ones that are out there, and it's freeware, so you can get all of these features, which is really all you need for web app pen testing. Cool. So Burp also includes an encoder and a decoder. So if you certain websites expect different forms of data. If you're putting certain characters into a URL, it just won't take it because they're special characters. So you can convert my super awesome text into URL, and then what I could do is then I could convert this URL encoded text into an HTML encoded text for wherever you would accept that. Cool. So some of the other tools you can use, Sql Map allows you to map and play with a SQL database remotely. Nicto is a general purpose web scanner. When you're using Nicto, it generally has a lot of false positives and it's extremely noisy. So it's really good for like a first step, like, okay, what is my attack surface on this web application? If you don't have the time to go through it all manually, you can run Nicto on it and be like, okay, here are some few hotspots, let's go and dig down into these. And then OWASP Zap, it's the Z attack proxy. It's a full open source alternative to things like Burp. So, some of the resources, things I was looking at this summer as I was doing a whole bunch of web API testing for my job. And the status codes and the REST API guidelines just on hand is really good. OWASP is absolutely fantastic for web application vulnerabilities. If you're interested in web security in the slightest, go to OWASP and just start reading all of their stuff. It's a very active community, and they're on point, and they're the name for web security. The Web Application Hackers Handbook, it's about $25, I think. It covers like full scope web app penetration testing from the basic stuff that we're talking today, the advanced stuff, or more advanced stuff that I'm going to talk to you next week about, and then like crazy, like more advanced stuff about that, like evading filters and such. If you want to practice any of these things, Utiliday is a good option. Damn Vulnerable Web App is a bit old. Utiliday has a lot more vulnerabilities in it, and it's a lot more stable and easy to use. Questions?
I think the new Metasploitable also has some web penetration testing aspects as well
Okay.
for those boxes.
Okay.
Go over last week's thing. Cool. Thank you, Nick. So I'm just going over last week's demo. If you guys just give me a couple minutes to get set up here. So I'm going to hopefully walk through this demo. So hopefully you guys enjoyed our social engineering thing. So just a couple of things. The reason we didn't give you guys hints is because hints kind of take away from the social engineering exercise. Is that there is a lot of data. There is a lot of things you have to filter through, and you have to make decisions when you're doing this about what data is good and what you need to spend your time on. So people found Karen Weber Jenkins and they went down this huge rabbit hole, which I thought was funny, and I didn't figure out until like Tuesday that Karen Weber Jenkins was a thing. So like, I apologize if people spent their weekend doing that, but that's part of social engineering, is being able to filter out that type of stuff. You know, figuring out when they became friends and stuff like that. So if you go look at Ben Weber Jenkins on Facebook, right here, you can see, yeah, so we can see that Ben Weber Jenkins made a post to his LinkedIn account. So that's visible. So if we go to his LinkedIn account, we can find out that flag 1 is right there. So just kind of seeing that what has he posted on, what has he done lately, we can go to his LinkedIn profile and there's flag 1. So pretty simple, pretty easy. So if you look at Ben Weber Jenkins' friends, you can kind of see that he's friends with Scott Weber Jenkins on LinkedIn and Facebook. So if we go to, come on. Using two screens is harder than it looks. So we can see that he is friends with Scott Freedom Slinger for a while. So if we go to Scott Freedom Slinger's website, and we go to his work and education, we can see that there's this nice, pretty little link down here. And if we So if you scroll down here, some people posted some stuff, and then we have flag 2 right here. So there it is, right there, flag 2. Actually, that's flag 4. Flag 2 and flag 4 are on the same page. I don't know how that happened, but anyway, flag 2 is there on the page. So if you look down, and if you didn't look any further, and you just stopped at flag 2, you kind of missed flag 4. So kind of an interesting little thing. You could jump right ahead. So So moving on to flag 3, we now know that Ben and Scott are now friends. So becoming friends with your target may be a really interesting idea to actually do. To becoming friends with them, because if Ben Weber Jenkins posts stuff and includes Scott in it, you can kind of see that. So if like Ben Weber Jenkins were to deny you, which he didn't, you can still kind of stalk him from a distance. So it may be an interesting idea to become friends with their family and things like that, because if you're trying to get to a security expert and they don't know who you are, they're going to click decline. If I get friend requests and I don't recognize your name, I click decline. It's not to be mean, I just don't know who you are. So most security people will do that, but their friends and family won't. So that's an interesting tactic that you can do. So if we go to, so if we become friends with Scott Freedom Slinger, and we go to his about page, his work in education. It was really funny because a lot of people just clicked on this link and they didn't really notice the little text underneath, and they went through this whole thing, which is actually a real school, and people just went down the rabbit hole again. So that's like the thing, is trying to filter out information of what you need to do and how much time to be spending on certain things that may or not be valuable to your time. So there's flag 3 right there. Pretty simple, not too hidden, not trying to trick you yet. And then again, flag 4 was ironically on this page that we were. So if you guys go to Scott Freedom Slinger, where is it? Did I have open it? Do I have my contact? Give me 1 second, I gotta bring up Scott Freedom Slinger's LinkedIn account. Sorry about this, forgot to open that account.
People also view music the fifth one now.
Oh, is he?
Yeah, the CEO at RC3. Move your mouse to the right, down.
Oh, there it is. I knew I had an intention. Son of a biscuit. Alright. Anyway, get out of here. And do the same. Go back to that page. Alright, let me log into his account real quick so that I can show you guys, because this is something really important, a nice little neat trick that I found that I think you guys should know about when you guys are doing social engineering, to really be thorough with what your investigation actually is. So, LinkedIn.com.
Thank you.
Sorry about this. Grab this website. Alright. So coming back over here, if we go to Scott Freedom Slinger, we look up and down, we don't really see anything that sticks out. So this is really cool and important to know, to really know your applications and how to really search through them and get the most beneficial information. So if you click this little contact button right here, it'll drop down and it'll show all their emails, their Instagrams, blah, 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 and all that. If you click that drop down button, we see that Scott Freedom Slinger has a Twitter account. Before you didn't see it, so I'll do it again. It's not there. Click that button, there we are. So then we come over here. When I see Scott Freedom Slinger, yeah, how many people are mad about that one? Alright, so we come here to Scott Freedom Slinger, we see that he has a flag right here. So right there on his public Facebook page, you don't have a public Twitter, so you don't have to be friends with him or anything. We see that Scott's only had 3 tweets, so it might be interesting to go look at what those 3 tweets are. And once we start following Scott and Scott accepts our following request, we can see his tweets, which are flag 6 right there. So, kind of thing to do. So, alright. So flag 7. Alright, so flag 7 is where it got really hard, because up until this point it was just finding them on LinkedIn, Twitter, Facebook, becoming friends with them, stalking them, figuring out what's going on, how to use these applications, and how to go through the menus and see where people might be putting certain information that might be helpful. So this is where it really got hard, and this is where we talk about the social engineering toolkit, where you had to generate emails that you could send to us. So first you had to figure out Ben Weber Jenkins' email. There were several ways to do that. You could have gone and say, I don't remember my password on Facebook, and it would have given it to you. You could have requested it from Ben Weber Jenkins, and he would have accepted it as well to give you his email. So there were several ways to go about getting his email, and several people did. So you had to create a social engineering email. You had to send me a link into it that would take me to a Facebook login page. So some things that I was looking for the email. A subject line that made me go, oh shit, I have to open this email right away. It's urgent. So a lot of people put urgent at the top and put different things. Great, I clicked on it real quick. Ben Weber Jenkins is not that smart. Put a nice body in there that's really convincing about why I have to click on this link. Make a claim, say you're from HR, say something like that, so that I go, I gotta click on this automatically and not even think about it. And he would, and he always did. If you made it convincing, it wasn't that hard. And once you did that, I clicked on it, take me to a login page, and Ben Weber Jenkins would just give you his creds. He'd give his creds to his Facebook account. So if you go to his Facebook account, so we can see that flag 8's right there. So flag 8 was a little bit easier than actual flag 7. So now that we know Scott and Ben are actually friends, we can assume that they've been talking together. So if we go through their actual chat, there's the flag right there. So that's something to think about, is that when you get access into someone's account, go look at their messages, see what they've talked about, see what they've done, and all that. See the things that they've transpired about. So hopefully the social engineering exercise was helpful. It kind of shows you ways to use Facebook and LinkedIn and Twitter to leverage information from other people, certain ways to circumvent certain security policies so that you can't see information like this. So hopefully you guys had a fun time. So we're going to go upstairs and do today's demo for web. So see you guys up there. Everything is online, presentations, and Google Form is ready to go. So. Probably. Straight to the end and got everything, and I thought that was really cool what you did. It was really awesome to skip to it. I was like, it's not a picture, but I was like, this is really interesting. That's fine.
is no dry erase workspace up here. I can explain it to you first.
Okay.
No one ever did
But
that.
is it like a separate software that you use, or is it like
No,
you do
it's
something in the
back
back
when
end?
they had these things last semester, this whole thing, and no one did that. No one set up accounts until this semester. So,
Set up their Facebook account. You can take up pictures from there. It's taken 4 weeks to delete. You have to send them. You have to go to into settings. You can just temporarily
that's fine. We won't be using it until next semester. It's just nice that like when people go there, there's not all these Weber Jenkins and that they don't spend time on it. But like when you guys came in with Clean Slate, I didn't care. Yeah. So like I said, I thought it was great. I thought it was awesome. But if you create an account, just makes it better.